Hello everyone, today we are going to derive the kinematic equations of motion by graphical method. First of all, we will consider a body which is traveling with initial velocity u from here, from something point here, initial velocity u that travels some distance that is that is s and reaches the point where its final velocity will be v in the time t. In the time t is equal to t seconds. Now I will draw here some imaginary lines. Now can I write here, and this is our velocity vt graph. Actually this is our velocity. Now it is a body which is traveling with initial velocity that travels some s distance and reaches the point where its velocity will be final velocity v. We mark here some points. Here t is equal to 0, a, b, c, d and e. Now from this graph only we are going to derive the three equations of motion. So there are basically three equations of motion, that are v is equal to u plus ad, 2as equal to v square minus u square, and s is equal to ut plus half ad square. First equation of motion, that is v is equal to u plus at. v is equal to u plus at. Now from this graph we can see that CD plus DE is equal to CE. Can we write this? CD plus DE is equal to CE. It is simply we can see from this graph, nothing else. CD is what? We don't know exactly. CD we don't know, but we know DE. DE is what? Initial velocity u. And CE, what is CE? CE is v. This whole is v. I will write here also that this whole is v. It is denoting v now, that's why here vt graph is there, so it is denoting v. Now can we say that CD is equal to v minus u, and v minus u is nothing but the change in velocity. And what is change in velocity? It is defined as acceleration. Since acceleration is v minus u upon t, we can substitute here. CD is equal to what? We will not write here, we will directly write v minus u upon t. And CD is what? This is what? CD is what? Change in acceleration. That is, we can say a. Now v minus u is equal to at. V is equal to u plus at. Hence derived. And at last you must write hence derived, because you are deriving the formula. You can write proved also, hence proved also, and hence derived also. It is okay to write. Now let us derive the second equation of motion, that is 2as is equal to v square minus u square. Second equation of motion says that 2as is equal to v square minus u square. And one thing you can see from here, that this area of trapezium means the area covered under velocity time graph, the area, that is the distance covered under the area or distance, you can say, covered under velocity time graph gives us the area of trapezium. So can we write here area of trapezium is equal to what? Half into sum of parallel sides into height. Now what is sum of parallel sides here? Parallel sides are u and v. So v plus u into h. H is what? h is here, this time, we'll write here time. Now we'll substitute the value of time with, we can see here, from here what will be time? Time will be t is equal to what? V minus u upon a. Yes, half v plus u into v minus u upon a. From here we will take this here, 1 upon 2a, v plus u and v minus u, v square minus u square, by the identity what? A minus b and a plus b. Area of trapezium gives us the area covered under the velocity time graph. That is, area covered under velocity time graph is nothing but the distance traveled. So s, this is in division. So from here 2as is equal to v square minus u square. Therefore, hence derived. Same as in the third equation of motion also, we have to take the area of trapezium and we have to substitute the value of v. The third equation of motion is s is equal to ut plus half at square. So from here area of trapezium is half into sum of parallel side, same as on the second equation of motion, into height, half into v plus u into t. We will substitute the value of v here. From here what we can see is v is what? U plus at. So here we will write v is equal to u plus at plus u into t, half into 2u plus at into t. Now this we have to multiply by this both. This both will multiply inside this. So it will come half into 2ut plus at square. From here it will come, this is s, this is nothing but we consider as s, means it is the area of trapezium is the area covered under velocity time graph below this one, that is distance. This 2 will cut. So s is equal to ud plus, sorry, half is also there na, yes, half at square, hence derived.